All right, so our next theorem that we're going to talk about is called the converse of the perpendicular bisector theorem. Fun stuff, fun stuff. So, any guesses what the converse is going to say?
That it's a perpendicular bisector?
The converse is perpendicular bisector.
All right, so what does that say? Well,
it's the converse. Converse is
So,
special.
If
Stating the opposite with Avery.
the line bisects and it's perpendicular, then it's a perpendicular bisector.
Become recap.
all right, so I'm glad that we're joined here by Captain Underpants.
Captain opposite.
Mm-hmm. All right. So, so the converse says that if a point is equidistant from the end points of a segment, why is it? May I continue?
Yes. That was enough.
Claudia is going to be like, I'm so glad I wasn't here. All right, if a point is equidistant from the end points of a segment, then it is on the perpendicular bisector of that segment.
Wait, what? Yeah, wait, what? I'm so confuzzled.
It's not that bad, guys. So,
Wait, what conclusion? What's the conclusion?
so in other words, what that is saying is that if we have a perpendicular bisector here, we know that point X is going to be equidistant from point A as it is from point B. So in other words, we know that AX, line segment AX, has to be congruent to line segment BX.
Boom shakalaka. Boom.
And we also know, oh my God, you know we're recording, right?
Yeah.
So we also know that line segment XY is perpendicular to line segment AB.
Yeah.
Okay. Next year's 8th graders are going to be like, what is wrong with those boys? All right. So then, today we're talking about perpendicular and angle bisectors. Obviously, we have some angle bisector theorems. All right. So the angle bisector theorem says that if a point is on the bisector of an angle, then it is equidistant from the sides of the angle. So I will say that again. If a point is on the bisector of an angle, then it is equidistant from the sides of the angle. So what does that mean? So let's say we have an angle. And I'm going to make my angle a little bit larger just to make life a little bit easier. And I have an angle bisector. So if I have an angle bisector, that means that this angle and this angle must be congruent. Yes?
Yeah.
Yes. All right. And just for the sake of labeling, let's label these. Let's go with point A. And let's call this point right here x.
B.
We'll call this point here
Y.
y. We'll call this point here z.
Why is A?
All right. So what the angle bisector theorem is saying is that if we have these lines that are meeting at a perpendicular angle, we know that yz is congruent to xy.
That's only the shortest distance, right? Like it's the shortest.
Well, yes, yes. So this was the perpendicular distance. So this is saying that xy is congruent to yz. So that's the conclusion that we can draw from this. Does that make sense?
Yes.
Yeah.
So clearly, the next thing we're going to have is the converse of the angle bisector theorem.
It's like a pattern. The converses are my favorite things.
And you guys thought you'd never have the converse stuff again. All right, so here's what this one's saying.
I know it's come back to haunt me.
So let's say we have an angle with a bisector coming through it, right? So if a point on the interior of an angle is equidistant from the sides of the angle, then it is on the bisector of the angle. So here's what it's saying. So what it's saying is, if we know that these two side lengths are congruent, then we know that the angles must also be congruent. So the conclusion here is, so if we're given the fact that these side lengths are congruent, then we know that these angles are congruent as well. So we can say that angle XAY is congruent to angle YAZ. Yes. So does that make sense so far?
Yay.
Okay.